Hello, we will be estimating a population proportion. Now, it's really important that you learn the correct symbol that goes with each of the following that we are about to do. So, the point estimate is a single number that estimates the true value of a population parameter. The point estimate for proportion is p hat. The confidence interval is a range of values to estimate the true value of an unknown population parameter. And we will look more at that. How our confidence interval is created with the point estimate plus or minus a margin of error. So for the confidence interval from 0.82 to 0.86, find the point estimate and the margin of error. Okay, the point estimate is the average. So we're going to find that first. It's always the middle number for the confidence interval. So we're going to take 0.82 plus 0.86 divided by 2, and we get 0.84. So our point estimate, p hat, is equal to 0.84, or 0.84. Now, to get the error is equal to 0.84, your point estimate, minus the lower level. So E is equal to 0.02. So your error is 2/100, or 2%. Your point estimate is 0.84. The margin of error is a measure of how accurate the point estimate is. Okay. So now we have what are called levels of confidence. So the probability is 1 minus alpha times 100%. So those have to do with confidence levels. So what we know is that 1 minus alpha is equal to the confidence level. So if we solve for that, negative alpha is equal to confidence level minus 1. So if we divide by negative 1, what we want to know is alpha in general is equal to 1 minus the confidence level. So notice that the confidence level is 1 minus alpha, and alpha is 1 minus confidence level. So for example, 90% confidence level, your alpha value is 1 minus 0.9, which is 0.1 or 0.10. Usually we have two decimal places, so we'll go with 0.10. 95%, you do 1 minus 0.95, and you get 0.05. 90%, we are going to do 1 minus 0.99, and alpha is 0.01. And alpha will be used to find our confidence levels and also hypothesis testing. All right, so in number 2, we're going to look at some notes here, just a few definitions. So these are important up here in the box. As the level of confidence increases, so does the margin of error. As the sample size increases, the margin of error decreases. And the larger the spread in the population, the wider the interval. Okay, here's the sentence we are going to write every time we interpret a confidence level. We will say, I am blank percent, so 90, 95, 98, 99, that the true proportion of, and then we'll have a statement, and I'll show you in just a minute, is between blank and blank. So this is the lower level. The first blank is the lower level. So that's your lower value, or your first value of the confidence interval, and this is your larger value, or higher value, second number. Okay, so for example, we want to be really careful because it does not tell us that there's a 95% probability. It's that you're confident that you'll find the parameter between the lower and upper bound. So, for example, 95% level of confidence implies that there's 100 different confidence levels, then we are 95% confident, or we would expect 95 of the intervals to include the parameter and 5 to not include it. So here's a visual, just so you guys can see what it would look like. All right, so in order to solve for the population proportion P, we have to use the graphing calculator. Okay, so for the point estimate. So remember, we will use p hat for point estimate, and that's for population. So you have a couple of conditions. N p hat q has to be greater than or equal to 10. And the sample size is no more than 5%. So n is less than or equal to 0.05 capital N, which is your population size. So the population size is capital N, and your sample size is small n. Oh, and the other thing is, let's review. So q hat is equal to 1 minus p hat. It has to sum to 1. X is the number of successes, and n is the number of trials. Notice your calculator keystrokes, stat, test, and we will do a 1 prop z interval, which is number A at the bottom of our graphing calculator. All right, so now we'll do several examples here. Okay, notice the example of how to input it in your calculator, what it will look like. So you input X first, N, and then your confidence level. And we hit the calculate button here. And your answer looks like this. Notice it gives you p hat. We'll also find it by hand to practice. And the confidence interval. So it gives us both the point estimate and the confidence interval. And from there, we can find the error. Okay, so in a recent survey of 700 community colleges, 481 have indicated that they have read a book for personal enjoyment during the school year. Okay, so this is your N, this is your X. All right, so what we want to do is we want to make sure that N times P hat times Q hat is greater than or equal to 10. So our P hat, our point estimate, is equal to X divided by N. So P hat is equal to 481 divided by 700, which gives us 0.69. Q is equal to 1 minus 0.69, which is equal to 0.31. So if you multiply, and we'll put this above, 700 times 0.69 times 0.31, it is greater than or equal to 10. That is true. So in this case, X is 481 and N is 700. So that means that it fits the conditions for a point estimate. Calculate the point estimate for the proportion of community colleges students who read a book for personal enjoyment during the school year. Okay, so we've done that, and I did that earlier, but let's go over it again. So P hat is equal to X divided by N. So P hat is equal to 481 divided by 700, again, which is 0.69. That's our point estimate. B, construct a 95% confidence interval of the proportion of all community college students who read a book for personal enjoyment during the school year. So what do we need to know? Well, we need to know X is 481, N is 700, and our confidence level is 95%, which translates to 0.95. So your alpha is equal to 1 minus 0.95. Your alpha is equal to 0.05. Okay, so what we want to do is our calculator keystrokes are stat, arrow to test, and we're going to do this says 1 prop z interval. So it's going to be 1 proportion or 1 prop z interval. Remember, that's your A. So if you do that on the calculator, so if you go to stat and then arrow to test now, so what we're doing going forward will be under test, your confidence level and your t-test and z-test. So it's down at A, it's 1 proportion because we only have 1 set of data. In chapter 11, we'll look at 2 proportions, or comparing 2 different sets of data. Okay, so our X is 481, Our N is 700. Our confidence level is 0.95. So we really didn't need to know alpha, but I went and went over. So on the calculator, what we get is very interesting. For our p hat, because it calculates for us, we get 0.6871 to 4 decimal places. And if you notice, p hat is approximately 0.69, which we know. And our interval is 0.6528, 0.72149. Okay. So you're going to say, I am 95% confident. So here's the first blank we're going to fill in with 95, that the true proportion of, and we're going to say community college students who read a book for personal enjoyment Okay, so I'm going to go ahead and let's see if I can get a different color here for us. Okay, there we are. So that you can see what the blanks are. So let me do this one more time. So this is your first blank, that the true proportion of, and then this was the second blank. It'll be pretty long. It's what you're discussing or given in your problem. Okay. Is between 0.6528 and 0.72149. And again, just so you guys can see what we're filling in, blank. So if we go back to page 2, top of page 2, it says, I am blank percent confident. So here we're going to put 95% confident that the true proportion of, and then you're going to make a statement of what the problem is saying. So this is a blank, is between blank and blank. All right, let's look at another one. A survey of 80 car accidents in Collin County showed that 46 were alcohol related. So 80 is your N, 46 is your X. Construct a 90% confidence level. Okay, so interval, so that's 90% is your confidence level. To estimate the true proportion of alcohol-related accidents in Collin County, write a sentence to interpret the interval. So the sentence to interpret is, I am blank percent confident that the true proportion of blank is between blank and blank. It's still filling in those blanks. And once you do some, it will begin to make sense. So again, we're going to do stat, or over to test, and down at the bottom, 1 prop z interval. Okay, so they put the confidence intervals in with the tests, which we will do in chapter 10. Okay, so using the calculator, we get 0.48409, comma 0.66591. Okay, so we've got this. Let's go ahead and list to the side then and fill in our blanks. So for this problem, X is 46, N is 80, and your confidence level, we're going to call it CL, is 0.95. So we say, I am. Oh, they changed it on us. Our confidence level is 90%, 0.90. I am 90% confident that the true proportion of alcohol-related accidents in Collin County is between 0.48409, 0.6, I should say, and 0.66591. All right, what is the point estimate and the margin of error? So the calculator will actually give us a point estimate. So p hat is equal to 0.575. The other way is you can average them, or you could even do 46 out of 80. So a couple ways to find that. So your error is your point estimate minus the lower bound, which was 0.48409. So the error is 0.09091. Okay, so a critical value is a number that separates the sample statistics that are likely to occur from those that are unlikely to occur. All right, so find the critical values corresponding to 90%. And so we have alpha and alpha over 2, and then we will review how to find z alpha over 2. So 90% alpha is 0.10, and alpha over 2 literally means 0.10 divided by 2. You take your alpha values when it's alpha over 2, and you divide, and you get 0.05. So if you recall, on the z-score, this and this is your, just a second, that would be a two-tailed test. So since this one, let me draw a picture. So z alpha over 2 is upper 0.05. If you guys remember from last week, you have inverse norm, area to the left, 0.95, comma, 0, comma 1. Okay, so the inverse norm is a little bit tricky. That's how we find our z values. Because it calculates the left tail. Okay, so if we go second bars, number 3 is your inverse norm. We put in the information. It gives us z is equal to 1.645. But generally, your z-score is 2 decimal places. So we're going to go with 2 decimal places. So z alpha of 2 is 1.64. You may see it 2 and 3, but we're defining it to be 2 decimal places. So here, to get our table, we're going to divide 0.10 by 2, you get 0.05. 0.05, you get 0.025. 0.02 is 0.01. 0.01 is 0.005. Your z alpha over 2 is 1.64, 1.96, 2.33, and 2.58. So just remember, whenever you're given alpha, that value is your alpha. Okay, it's always to the right. So you have to do inverse norm of 1 minus alpha (0, 1). All right, number 5, page 5. We would like to find the sample size. Okay, so if you know the point estimate, p hat, before you start the problem, sometimes it's given, sometimes it's not. We'll use this formula. P hat times Q hat, parentheses, z alpha over 2 divided by E, where E is your error, quantity squared. And again, see right here, Q is equal to 1 minus P hat. Q hat is equal to 1 minus P hat. If you don't know your point estimate, we use 0.25. That becomes a half times a half, which is 1/4. So, what sample size should be used? So let's read. A television sports commentator wants to estimate the proportion of Americans who follow professional football. What sample size Okay, so that means we're looking for n. Should be attained if he wants to be within 3 percentage points. That's your error. With a 95% confidence. Okay, so your confidence level is 0.95. Your E is equal to 0.03. Percentage points, when we convert, means out of a percent, which means out of 100. So 3 divided by 100 is 0.03. Okay, and he uses a 2010 estimate of 63%. Okay, so that means p hat is equal to 0.63. Since we are given p hat, we are going to use the formula that involves p hat. So the formula we want to use is n for the number p hat, q hat, z alpha over 2 divided by e squared. All right, so we have p hat. Recall q hat is equal to 1 minus p hat, which is 0.63. So q hat is equal to 0.37. Okay, so we know from the previous page, or we can find it again, that for 95%, z alpha over 2 is 1.96. These values do not change. So n is equal to 0.63, 0.37, 1.96 divided by 0.03, and quantity squared. That's just a formula. You plug in your information. So n is equal to 994.9744. Now in this case, we will always round up. So we will need 995. So we would need to poll 995 people to answer the question. Now if he chooses not to use any prior estimates, that formula is E is equal to 0.25 Z alpha over 2 divided by E quantity squared. So the, I'm sorry, not E, N. So we have the formula, N is equal to 0.25 1.96 divided by 0.03 quantity squared. So make sure you put those numbers in parentheses. So n is equal to 1067.1. Again, we have to round up because you need part of a person, so you have to go ahead and round that to the whole. So we would need 1068 to be able to get our sample size with no point estimate. So the sample size, if we use the 63% point estimate, it would need to be 995. If we use no prior estimates, we would need a sample size of 1068.